No, we're not. All right. So, quick review of the stuff we already wrote down. Average rate of change is like the slope formula you've dealt with last year and this year, yes?
Yes.
Y2 minus Y1, X2 minus X1. We read the graph and figured out at 1 second it was traveled 5 centimeters. At 3 seconds, again it's a toy car, it traveled 13 centimeters. And at 5 seconds it had traveled 17. All right, so listening. We also talked about the graph. We looked at it that it was increasing at a faster rate at the bottom and then it started increasing at a slower rate at the top. Yes or no?
Yes.
And then when we actually did the math, between 1 to 3, we did the math here, we got 4. Between 3 to 5, we did the math here and got 2. And we said, yes, indeed, in the beginning it was going faster than it did at the end. Are we good?
Yeah.
All right. Now, I'm going to move on to this part because this is another part you're going to have on the test. First thing you're going to do is fill in the chart. You've dealt with quadratic functions in this class. We just spent a whole week on it. This, you dealt with. This, guys, this we dealt with last year. Okay, so we're moving on. Okay, so F goes with this T-chart and the G goes with this T-chart. This is why we use function notation, so we can talk about two separate functions and not call them both Y. This is F, this is G. All right, plugging 1 into the F function, what's 1 times 1?
1.
2 squared, what's 2 times 2?
4.
3 squared, what's 3 times 3?
9.
4 squared, what's 4 times 4?
16.
And 5 squared is?
10. 25.
25.
Sorry.
All right, it's okay, listening. Shh, guys. All right, now we're going to do the same thing but with the G function. And the G function is not x to the second, it's 2 to the x. You did that one last year. Exponential function. Guys, I'm making my seating chart coming around, and I can tell you right now, there's some of you that will not be sitting together, nor will you be sitting in the back. I'm telling you guys that right now. So knock it off and pay attention. All right, 2 to the first power is what?
2.
2 to the second power, 4. This is 2 to the third power. 2 times 2 times 2 is?
8.
This is 2 to the fourth. 2 times 2 times 2 times 2 is?
16.
Is this pretty much 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16?
16 times 2.
2 is 32. 2 to the fifth is 2 times 2 times 2 times 2 times 2 5 times, which is 32.
What about for the X one?
For which one?
For the first chart, you can't do that. 2 times 2.
No, this for this it's just 2 times 2, 3 times 3, 4 times 4, and 5 times 5 because it's to the second power, where this is to the x power. Do you see the difference? This, the power is always 2. This power is changing depending on the problem, depending on the number. All right, we're going to fill in this average rate of change now.
4C.
Huh?
4C.
What?
C. No. 4C.
What about 4C?
Oh, I said 4C.
You have a question on that one? I'm going to go over it. Okay. Shh. Okay, remember you always make your two ordered pairs. And the first one, it says between 1 to 3, so I'm putting 1 and 3 into the X spots for both. Now I have two T-charts. How do I know which T-chart to use first? It says right there, F. All right, so F is 1, 1, and 3 what? 3, 9. All right, go ahead and do that. 9 minus 1 over 3 minus 1. Go ahead and calculate that and reduce. Right here. 1, 1, and 3, 9. So you will get points on the test just for filling these two out. And then, of course, you're going to have to show work and get points here as well. All right, what do we get? 8 over 2, which is 4. Okay, now again, why are we doing it again, 1, 1, and 3 if we've done it already? Now we're using the G function. So we go to the GT chart, and it's not 1, 1, it's 1, 2, and 3, 8. And do the same thing. Go ahead and do that now.
That one's 3.
Yes. So 6 over 2 is 3. Shh, guys, zip it. Okay. The average rate of change, the average rates of change are different. Ladies, the average rates of change are different. What does this mean in relationship to the graphs? Okay, this question is going to be on the test as well. Okay, which one is bigger? F or G? F. What does that mean about the F function between 1 and 3? It's increasing at a faster rate or slower rate? Faster rate. Forever or just between 1 and 3? For now, just between 1 and 3, because we can see, we'll try this one here between 3 and 5 and see if it's still the same. All right, so this is what you would write. F of x is increasing at a faster rate or slower rate? At a faster rate than g of x between, and it's important to say between what two numbers? Between what two numbers is it increasing at a faster rate? Between 1 and 3. 1 and 3. And I'm going to change the wording just a little bit. You can leave it, but just know when x is between 1 and 3. All right, f of x is increasing at a faster rate than g of x when x is between 1 and 3. Keith? Jared? Head up off the desk. All right. Mateo, again, put your phone away. Okay, next one here. Rate of change, same as 4a and 4b, but now it's between two different sets of numbers. 3 and 5. 3 blank, 5 blank, 3 blank, 5 blank. I'm going to give you guys a few seconds. This one tells you to use the f function, and this one tells you to use the g function. I want everyone doing this now as quick as you can. Joseph, can you give me those two numbers here? 3 blank, 5 blank. What two numbers do you have?
I didn't do it.
Okay. Okay, I want you doing it right now. You're looking at your X chart and tell me what you're going to write down with a 3. 3 what?
3, 9.
Okay. And then 5.
5, 25.
Okay, and then you're going to give me the math. What minus what?
25 minus 9.
Over.
5 minus 3.
Okay, and you guys have it. 25 minus 9 is 16 over 2, which is 8. All right. Guys, next one. Alicia, give me the answers you have for the 3, 5 for the G function.
3 and 8.
Uh-huh.
5 and 32.
Perfect. Can you give me your fraction? Stop the talking.
32 minus 8 over 5 minus 3.
Thank you. And Chris, give me the numbers.
It would be 22.
Okay.
No,
I could, and you again, you were talking instead of working.
No, but I know it. 24 over 2, and then it's going to be 12.
All right. Now, which one's increasing at a faster rate now, the F or the G? Okay. So going back to this answer up here, is the F always faster than the G?
No.
No, just at the beginning, and then what happens at the end?
It,
Which one went faster? Okay, so do you guys remember exponential from last year?
Yeah.
It looked like this. Do you guys ever heard it grows at an exponential rate? That's because it grows really fast. Parabolas grow, they get wider and wider, but over time, this one goes at a faster rate. Please stop. Make sense?
Yes.
Okay, so what would we say here? Which one is faster, F or G? Okay, so the average rates of change are different. What does this mean in relationship to the graphs? G of X is increasing at a faster rate. At a faster rate than F of X when X is between what? 3 and 5.
Do you have to put when X is between, or could you just put between?
You could even just put from X equals 3 to X equals 5. Okay.
Is that what our homework is?
Is this homework?
Okay. Let's flip over to the back side.
We only have like 2 minutes.
7. Okay.
like, it's been 24 hours. Like, did you get
Stop the talking. Stop the talking. Guys. Okay. In 8 minutes you can. Okay. Listen. What do you notice about the linear graph as far as the average, the rate of change? Is it constant?
Yes.
Okay. What about a parabola? Does it start off constant or does it actually increase as it gets bigger? Okay. What about exponential? Is it increasing in the beginning or is it actually really small in the beginning? And then what happens over time?
It gets bigger.
It increases at a faster rate. Which one do you think increases at a faster rate over time?
Exponential.
In the beginning?
No.
Which one between these two? Which one do you think in the beginning?
Quadratic.
Between these two.
Oh, quadratic.
Okay. Guys, now, because of time, I am just going to give you the numbers at the bottom. Know that you would have had to have figured those out on your own. You would have done parentheses 0 comma blank 1 comma blank 1 comma blank 2 comma over and over 5 for these, 5 for these, and 5 for these. We're not going to do that. Okay. We're not going to do that. I'm just going to give them to you. Are you ready? Okay. 3, 3, 3, 3, 3, 3, 9, 15, 21, 27, 2, 6, 18, 54, 162. All right. Now, we're going to look at what's going on. Stop. Okay. What do you notice about the average rate of change of a linear graph? They are the same. What would we say? What's another word for same? They are constant.
They're linear.
Constant. That's why it's linear, because the average rate of change is the same. Okay. What do you notice about the average rate of change for a quadratic? Can you find any pattern here?
They multiply by
3.
Okay, 3 times 3 is 9. 9 times 3,
All divisible by
no.
3.
They're all divisible by 3, but they're adding by what?
6.
So increasing, that's increase. By 6, I'll put in parentheses, plus 6. All right, and what about this one?
Those are multiplied by 3.
2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. So I'm going to put here multiply by 3. I'm going to put a times 3 in parentheses. Please stop. Compare the average rate of change for the quadratic function and For the exponential function, which average rate of change increases more quickly? Does it depend on where you're at? Okay, look at the beginning. Which one's increasing at a faster rate in the beginning? 3 compared to 2, 9 to 6. Which one's faster? Quadratic. And then it's 15, 18. This one's a little faster. And then what happens over time? Is there a big difference? So in your own words, guys, listen. In your own words, not right now, you're going to put here, in the beginning, which one's faster? And over time, which one's faster? Okay. Over what interval is the average rate of change for the linear function greater than the exponential?
Oh, the first one.
The first one, between 0 and 1. Which function has the greatest average rate of change over the interval 1 to 2, 3, 9, and 6? Which one's bigger? Is that always bigger? No. Okay. Any questions? Listen. Your homework tonight is filling those 3 in. That's it. That's it. That's it.